Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. Today we are doing Lesson 16, Applying the Properties of Operations. Okay. Properties of Operations to multiply and divide rational numbers. So let's take a look at those properties first. And I am going to project these or post these up here. If you feel the need to pause this and review, then do so. We've already discussed the associative property. Notice A, B, and C. A, B, and C. So the order of the values are the same. The only thing that moved were the parentheses. So if we use our order of operations, which we call PEMDAS, then the parentheses are done first. So I'd add A and B first and then C, and over here I'd add B and C first and then A. The commutative property just means order doesn't matter. A plus B equals B plus A. How about 4 plus 3? 7. 3 plus 4? Still 7. The additive identity property of 0. Okay, what the identity means is what do I add to a number and not change it? And that is 0. So A plus 0 equals 0 plus A, which is equal to A. So no matter where the 0 is, we add 0 to something, it is always equal to that number. 5 plus 0 is the same as 0 plus 5, and they both equal 5. Additive inverse means we're going to add the opposite to get an answer that's the identity, or 0. So 5 plus negative 5, or negative 5 plus 5 equals 0. That's the additive inverse. Okay. Associative property of multiplication is the same as associative property of addition. See here and this one here? They are both the same, except multiplying instead of dividing, or adding. Multiplying instead of adding. They are all the same. ABC, ABC, move parentheses. Commutative property of multiplication is the same as the commutative property of addition, except instead of adding, we're multiplying. 2 times 3 is 6. 3 times 2 is still 6. Multiplicative identity. What can we multiply things by to get the same thing? And that is 1. 5 times 1 equals 1 times 5, which equals 5. It's the same as the additive identity, except when we add nothing, we get the same value. When we multiply by 1, we get the same value. Multiplicative inverse just means to take the reciprocal of a number. So the inverse of 5 is 1/5. 1/5 times 5 equals 1. So if you multiply by the inverse, you get the identity, 1. If you add the inverse, you get the identity, 0. Okay? When we do the inverses, the result is the identity. And then finally, the distributive property of multiplication over addition is A times B plus C equals, and we distribute. I don't know why I can't write with this. Let me see. Let me pick a marker. Let's see if that will let me. Okay, let's use red. A times B is right here. A times C is right there, and the sign just goes in between. A times B plus A times C equals A times B plus. That is the distributive property of multiplication. Okay? Okay, now let's take a look at our lesson. Now we've discussed the problem. So here we go. Evaluate the expression below. Now, PEMDAS says that if we have multiplication, 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 if we reduce something down to all multiplication like this, we can just simply work left to right. But we are learning properties today. I am trying to clarify properties with you. So we're going to use some property information here. So the first thing I am going to do is get rid of a double negative. Okay, so I'm going to bring down my -6 times 2 times, and then I'm going to multiply these two. Negative times negative is positive. -2 times -5 is positive 10 times -3. So I got rid of one of my negative numbers. Okay. Now I'm going to rearrange this. And I'm going to leave -6 times 2 where it was, but I'm going to rearrange my last two. Okay, so I'm going to move my -3 here. And I'm going to move my 10 over here. Okay, so now I have a -2 and a -3. So when I do that, I get -6 times -6 times 10. So this is rearranging is commutative property. Commutative property of multiplication. Rearranging this, okay? So now I have -6 times a -6, which is a positive 36 times 10. Okay? So really what I can do is put parentheses around the thing I'm doing and call it associative. Because we're changing our parentheses. Even up here at this top part, I decided to multiply these two first. So if I put parentheses around that, that means do that first. That's associative as well. Okay? If you put parentheses and group something and work on those two things, then that's the associative property when you put them in parentheses. Now 36 times 10 equals 360. And we have our answer. So what type of strategies were used to evaluate this expression? Okay, there's a lot of writing here, so I'm going to just bring these in typed. Okay, so copy this down. The strategies used were order of operations, rearranging the terms, using the commutative property, and multiplying the terms in various orders using the associative property. Now let me go back up though. There's more than one way to solve problems, and the reason I focused on this first is because I wanted to focus on the topic today, which is properties of operations. But I can use PEMDAS as well. I'm going to do this whole problem over again, just doing order of operation in PEMDAS. So if I erase this parentheses here, so I'm now doing this problem again. So if I just simply do the first two terms, I get -12 times -2, one step at a time, times -5 times -3. Okay? And then I'm going to group the first two, which would be the associative property. -2 times -2 is 24 positive, times -5 times -3. Okay? Now notice I didn't put an x in here, so we're going to also be getting rid of x's, because leading into algebra, an x is a variable, and if you use x for multiplication, it gets confusing. So two parentheses next to each other also means multiply. Okay? So now I'm still working left to right, because that's what PEMDAS says to do when our signs are all multiplication. So now 24 times a -5 is -120, and I'm going to multiply that by -3. And then finally 120 times 3 is 360, and the negative is positive. Okay? Negative times a negative. So I got 360, I got 360. Okay, now let's get back to these strategies. Can you identify the benefits of choosing one strategy versus another? Okay, so copy this down. Multiplying the terms allowed me to combine factors in more manageable ways, such as multiplying -2 times -5 to get 10. Multiplying other numbers by 10 is very easy. Okay, so that's the reason we chose that -2 and that -5. We did two things. We got rid of a negative, and 2 times 5 is 10, and then multiples of 10 are easy. You just add a 0. And that's why that step was done first. Okay, the next thing says, what is the sign of the product and how was the sign determined? Okay, writer's cramp here. The product is a positive value. That's the easy part. But then you have to explain, how was that sign determined? When calculating the product of the first two factors, the answer will be negative. because a negative times a positive is negative. Then I multiply by a negative, we'd say a negative times a negative is positive. So now we have a positive times a negative, which is negative, and then finally that negative times that negative is positive. So we have 1, 2, 3, 4 negatives and 1 positive. So when we have an even number of negatives, we're going to get a positive. Okay. If you want to pause this and copy this down instead, that's fine. Okay, now now exercise 1 says find an efficient strategy to evaluate the expression and complete the necessary work. Okay, so do exercise 1, pause the video, come back, we'll discuss it, and then after the discussion, try exercise 2. Okay, so there is more than one way to do this. There's more than one way. I can just do order of operation left to right. I can rearrange so my negatives are together and get rid of those. I can get rid of negatives by multiplying those. There's many different ways. There's not only one way to do this. I personally would like to get rid of the negatives first. So I'm going to do these two. So if I put parentheses around this, and I get negative times a negative is positive, 1 times 3 is 3. And then I'm just going to rewrite the rest. And that is associative. Okay? The associative property, because I put parentheses around the first term. Now what I'm going to do is get rid of the other, and simplify the other negative, which is here. So I have 3 times 10 times a negative times a positive is negative. 2 times 2 is 4. Okay? So that is also associative. Again, there's more than one way to do this. This is just the way I decided to do it. You have to be able to tell what property you're doing, though. Now I'm going to leave that 10 for last because that's easy. So I'm going to now rearrange this and say 3 times negative 4 times 10. And that is commutative property. Okay, and I'm going to do this. Negative 12 times 10. And then finally, a negative times a positive is negative. And whenever we multiply by 10, we just throw a 0 on the end. So the product is negative 100. Again, there's more than one way to do this, but I chose this way. Okay, now pause the video, try to. Okay, now that we pause the video, I see fractions in this one, so I'm going to combine the fractions first. So I'm going to rearrange this. 4 times negative 8 times 9 times 1/3 times negative. There. Okay. 4 times negative 8 times 9 times negative 1/3. So the 1/3 went over here, and the 9 went over here. Okay, so the 1/3 simply moved over to here, I guess. So when we rearrange things, that's alright. So now I'm going to multiply the fractions. So I'm just simply going to write 4 times negative 8 times 9 times 1 times 1, my numerator, and it's going to be negative because a positive times a negative. My numerator is 1, and my denominator is 3 times 2, 6. Okay. Now I'm just going to let this sit there for a while. We're going to do that step last because we're going to take our answer and divide it by 6 as well. 1/6 multiplying by 1/6. So the next step is going to be, I'm just going to simply multiply these two numbers, and that's going to be negative 32. And basically what we're doing is grouping those, and grouping is associative. Times 9 times negative 1/6. Okay, and moving right along, I'm now going to group these two integers 9 times 2 is 18, carry the 1. 9 times 3 is 27, plus that 1 is 28. Negative times a positive is negative. And I'm multiplying by negative 1/6. That was also associated property of multiplication, to be exact. Okay? Now 288, think of that as over 1. So that's going to give us negative 288 over 6, but a negative times a negative is going to become positive. So I'm going to divide 288 by 6. 6 times 4 is 24. 6 times 4 is 24, enter 4, and 6 times 8 is 48. My answer is 48. Again, there's more than one way to do it. If you did it a different way and got 48, great. But are you able to say what you're doing? So then exercise 3, this will vary as well, because if you did something different, then your answer would be different. So what did I do first? I rearranged it so the fractions were the same. And that's what I'd write here. I'm not going to take the time to do that now. But I would say I rearranged the fractions. I used the commutative property to get the fractions together. Okay? There are other ways we could have done this, and I'm going to point out a few. So I'm not just going to mess around with this, just follow along. If I see something in the denominator of 3, I try to get rid of a fraction. I can get rid of a fraction by finding a multiple of that 3. So I could have combined the negative with 1/3 and the 9. And same with the half. I could have combined that with either the negative 8 or the 4 and got rid of the fractions in those cases. Okay, so whatever you do, it all will work out as long as you don't make any arithmetic errors. Okay, exercise 4. Refer to the example and exercises. Do you see an easy way to determine the sign of a product? First, okay, I kind of touched on this already in this problem here. I said 1, 2, 3 negatives. So when there were 3 odd number of negatives, that was negative. And then if I come down here, let's get all this stuff out of the way. I have 1, 2 negatives. That's an even number of negatives. And my answer was positive. Okay, so there is a pattern here. And let me bring in the explanation. Okay, here is the lengthy explanation on that. The product of 2 negative integers yields a positive product. So the product of 2, an even number, yields positive. Okay, so that's the key here. If you want to shorten this a little bit. 2 negatives yields a positive. If there's an even number of negative factors, each negative value can be paired with another negative value to get a positive product. This means that all factors become positive and therefore have a positive product. For example, negative 1 times negative 1 is a positive 1. And if we have 2 more negatives, they become positive. And a negative times a negative is positive. So now we have a positive times a positive times a positive, which is positive. There were 1, 2, 3, 4, 5, 6 negatives, which is even, which gives us an even or a positive product. Here I have 2 that became positive. Here I have 2 negatives that became positive. Here I have 2 negatives that became positive, but now I have this 1 negative all by itself that stays negative. So now I have a positive times a positive, which is positive. Positive times a positive, which is positive. And then finally the positive times that 1 negative will give me a negative answer. So I have 1, 2, 3, 4, 5, 6, 7 negatives, and it yields a negative. And this up here adds 6. So even number of negatives gives us a positive answer. Odd number of negatives gives us a negative answer. Okay? Example 2. Rewrite the mixed number as a sum, and then multiply using the distributive property. Okay, so now we're getting into the distributive property. So remember, the distributive property is A times B plus C equals A times B plus A times C. Right. So now what they're saying is mix this as a sum. So it's going to be rewritten as -6 times 5 plus 1/3. That's what that means. The 5's positive, therefore the 1/3's positive, so we can split those up. Now I'm going to use the distributive property, and I'm going to take -6 times 5, and I'm just going to write it for now, plus -6 times 1/3. Okay, I guess I'm see if it's not a negative. -6 is my negatives in parentheses. Okay, so -6 times 5 plus -6 times 1/3. So then I'm going to do this step. -6 times 5 is -30. And -6 times 1/3, 3 will go into 3 once, 3 goes into 6 2, and that comes out to be -2. So my answer is -30 plus a -2. Be careful. Adding two negatives does not give you a positive like multiplying. -30 plus another -2 is -30. Okay? Now you try it. Pause the video. I will leave this up like this. Pause the video so you can follow along and do exercise 5. Okay, so here's what exercise 5 should look like. Multiply the expression by using the distributive. So I'm going to take 9 times -3 plus -1/2. Be careful there. -3.5 is -3 plus a -1/2. I'm going to distribute 9 times -3 plus 9 times -1/2. And now I'm going to do this multiplication here. Positive times a negative, negative. 9 times 3, 27. Plus positive times a negative, negative. 9 times 1, 9 over 2. Okay, I couldn't reduce there, so it's -9/2. Alright, now I want to represent that -9/2 as 2 goes into 9 4 times, the remainder of 1. So that's the same as -4.5. So -27 plus -4. Do that first. Plus -1/2. Okay. So now I'm combining my whole numbers. -27 plus a -4, -31 plus -1/2 is -31 and 1/2. Oops, -31. Okay, now we're doing the distributive property, but now we're going to work it backwards. So backwards would be A times B plus A times C equals A times B plus C. Okay, we can work it both directions, and this is already split up, and I see 16 twice. So I'm going to say 16 times quantity, -3/8 plus 1/4. Okay, so when I see a 16 twice, I know I can, that's actually called factoring. Okay, so this is your introduction to factoring. Using the distributive property backwards is factoring. So now I'm going to combine these, but in order to add fractions, I need to have the same denominator. So that's going to be -3/8 plus, I had to multiply 4 by 2, so let me just show that. I need to multiply this by 2 over 2. 4 times 2 is 8. 1 times 2 is 2. And now I can say that is 16 times negative 3 plus 2 is negative 1/8. Okay? And then reduce. Think of this as over 1. So 8 will go into 8 once. 8 will go into 16 twice. 2 times 1 is negative 1 is negative 2 over 1, which is simply negative 2. Okay? Example 4. Rewrite the expression as only multiplication and evaluate. We don't want division. Okay, so remember that when we're divided by a fraction, we use the multiplicative inverse property, or flip it and switch it. So this would be 1 times 3 over 2. And I'm going to switch x's to dots. I don't like else's math. Times negative 8 times 3. I don't want a division, I want a multiplication. And I need to flip this. It's still negative. It's going to be negative 2 over 1, which is simply negative 2. Okay? Now I'm going to rearrange this. I'm going to say 1 times negative 8. I don't need that dot there, but I'll put it. So I'm putting this here, and then I'm going to say times 3 halves times 3 times negative 2. So what did I just do? This went here, this went here. What property is that? Okay? Why did I do that? Now I can do this with that. Why did I do that? What should I have done instead? I can do this. I can reduce it. But let me rewrite this. Let me move the 3 somewhere else. Okay, so fix this. I see a 2 down here. I see a 2 right here. Let's get the 2's together. So the 1 and the 3 have moved over here. And then I can put the negative 2 here and then the 3 over here. So I can rearrange more than one thing and still consider the commutative property. So this 3 went here and that 2 also went there. So we switch these 2 and we switch these 2. And now we have this that we want to do first, and that's associative property of multiplication. The 2's are going to cancel. They'll become 1. 3 times negative 1 is negative 3, so now we have this. Okay? Now let me get these out of the way. So now I have 1 times negative 8. So I'm going to do this next, and that's just going to be negative 8 times negative 3 times 3. Okay, so what property is that? Multiply by 1 and get the same thing. That is multiplicative identity. Multiplicative identity. 1 times negative 8 equals negative 8. Okay. Now I'm going to multiply these 2. Negative times a negative is positive. 8 times 3 is 24. Times 3. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. Okay. Hopefully you got 7. Okay. Now pause the video and try exercise 6. Okay, here's 6. First thing I see is a division. I want to get rid of that. 4.2 times negative 1/3 times, flip it and switch it, 6. I'm not going to write it as 6 over 1. We all should be able to do that now. So I'm just going to do it as a 6. Times negative 10. Okay? Now I'm going to focus on the 3. So this is associative property. So that first step was multiplicative inverse. Let's write that. Okay, we flipped 1/6 and called it 6 and went from division to multiplication, multiplicative inverse. Now I'm going to do 4 times 2. Negative times a positive is negative. This 3 is a 1 and this 6 is a 2. So it's -2. Those cancel. Times -10. So since I grouped the center and did that first, that's associative. Property of multiplication. I'm just going to not write the whole thing, but to be specific, there is an addition one and a multiplication one. You need to specify which you're using, and obviously we're doing multiplication. Okay. I'm not a fan of negatives, so I see that there's 2 of them, so now I'm going to group these first. So I'm going to say 4 times 2 times negative times a negative is positive, 2 times 10 is 20. And that is also associative. Property of multiplication. And then 4 times 2 is 8. And 8 times 2 is 16. That's 0. And 16. Oh, error. Where did I make the mistake? That looks like a times, and it's a decimal. So let's go back to here. Be more careful with my decimals. That is a 0.2, not a 4 times 2. Okay. So going back up to here, everything's good. It's 4.2 times 20. And then that is going to be 84.0 or 80. Okay, my apologies there. Okay, that's the end of the lesson. Here's the summary. Now try your exit ticket, turn them in, and then go do your problem set.